Definition of the exponential function. The exponential function f with base b is defined as f of x equals b to the x. What I want to notice is the variable is in the exponent. So now when I put in x and get out y, I'm putting x in, it's a power. It's an exponent, it's a power. B is a positive constant. So in other words, b has to be greater than 0. B is not equal to 1. Well, if b is a base, that means that's something you're raising to a power. Raising 1 to some power doesn't make any sense. 1 to the 100th power is still 1. So the base can't be 1, and the base is going to be defined to be positive. Examples would be f of x is equal to 2 to the x, g of x is equal to 4 to the x, h of x is equal to 5 to the x plus 1. And the first thing we do is we define it, then we evaluate it. Okay? So now we're going to be looking at if f of x equals 2 to the x, find f of 3. F of 3, you put 3 in for x, that would be 2 cubed, which would be 8. F of negative 3 would be 2 to the negative 3, that's 1 over 2 cubed, that's 1/8. F to the 0.5, now we're into our calculator. You can either put it in as 0.5, or you can put it in as 1/2. If I were to do it by hand, 0.5 is 1/2. 1/2 of course, is the square root of 2. And then the square root of 2 is approximately 1.414 ... If you're using your calculator, most of you have TIs, but some of you that may have this on your phone calculator, if that's what you're using, the x to the y, I put the base in, I put my symbol for the exponent, which is either the upward caret or x to the y, put in my exponent, and then press enter. There is a special number we're going to be working with, and that's a lot like pi. And that's a number called e, and we'll do more investigation about where e came from and some of the rest of it. But it's like pi, and 2.718281827 ... And it goes on forever. We often approximate it by either a 2.7 or 2.72, depending upon the accuracy. If I'm graphing, I might use 2.7. And if I'm doing an application problem, I may take it out to 2.72 because I need more accuracy. But if I'm graphing, lots of times 2.7 is a good approximation. So if I want to do 5 to the square root of 2, taking out my handy-dandy little calculator, and let me move this to classic mode. So I'm going to find my mode button right in front of me. And it looks then more like the baby TI, the little blue one. So it would be 5. And let me get this in here. 5. Then I pick up the caret, which is above the clear key. That gives me my exponent. And then square root is above x squared. Oops, wrong one. Square root is above x squared. And 2. Now you don't have to put the parenthesis behind unless you've got something else behind. And then press enter. And it says, 3 decimal places? 9.739. So we'll say it's approximately 9.739. How many decimal places you take it out to depends upon the accuracy. Now E. Now E is kind of an interesting creature. It's going to be above this button called ln. And ln stands for natural log. And natural log and E have a relationship, which we'll talk about later. But if I want E, it's going to be second natural log, or second ln. That gives me E. Second ln gives me E. Now it gives me E to the, and what do we want to find E of? 3.4? And 29.964. So we can say that this is approximately 964. Now remember, if you can't remember, you can't find E, or you don't have a calculator that's got E on it, but you do have an exponent, you could say, well, I'm going to approximate it 2.7 to the 3.4. Let's see how close we get. Close to 29.284. We're going to be off at the first decimal place, but 29 is there. Now, if I were to say 2.72, that's a little should be a little bit more accurate to the 3.4. Now I'm over. All in the rounding, because what is this? 2.71 something. So 2.72, you're going to be a little bit over. But if worse comes to worse, and that's what you do, approximate it. But realizing that there's going to be error built in because you rounded E itself. And then you're going to round the answer again. So you've got double rounding involved. It's called round-off error.